Alright guys, so in today's video we'll be talking about Boyles Law. Now this video will just be pretty strict to calculations, not much about the story aspect of Boyles discovering relationships between gases and all of that. So we'll just go direct to Boyles Law, state the law, and then how the law leads us to formula, and then use the formula to solve problems. Okay, so what is Boyles Law? Now, Boyle's law states that the volume of a given mass of gas is inversely proportional to the pressure, provided that the temperature remains constant. Okay, so writing this formula mathematically, we have the volume of a given mass of gas is inversely proportional, is how it is written, to the pressure. Now we're going to use this law to provide a formula where we will solve problems with. So for us to turn this into a formula, we introduce a constant. The proportionality sign changes to equal to, and we put a constant. Now the constant can be any letter, but normally in chemistry, we love using K. So K multiplies 1 all over P will give us K all over P. So this is it. Now we need to make the constant subject of formula. So we cross multiply. K times 1 is K. Is equal to P times V is PV. Now this is the formula. Constant is equal to P times V. And what this means is that the product of the pressure and the volume is constant. So that simply means if we have P1, V1, it is the same thing as P2, V2. The product of the first pressure and the first volume is the same as the product of the second pressure and the second volume. Okay, so this is Boyle's law. This is what we'll be using mainly to solve problems. P1 V1 is equal to P2 V2. So when we have problems, this is what we refer to. All right, so let's go into an actual problem under Boyle's law. So let us solve a Boyle's law question. This question says a gas exerts a pressure of 3 kilopascals. So we've gotten pressure 1, E1 is equal to 3 kilopascals. Continuing, on the walls of container 1. When container 1 is emptied into a 10-liter container, all right, now we have 10 liters. That stands for volume. Now, container 1, the volume was not given for container 1, so V1, the volume for container 1 is not given, put question mark. But the volume for container 2 is given to be 10 liters. All right, let's continue from 10 liters. To a 10-liter container, the pressure exerted by the gas increases to 6 kilopascals. So pressure 2 is now, the pressure has increased to 6 kilopascals. Now what are we told to do? We are told to find the volume of the container 1. So we should assume that the temperature and the amount of gas remains the same. So what we're looking for is the volume of the first container. So we go ahead to state the Boyle's law formula, which is P1 V1 is equal to P2 V2. All right, let's solve this. So we're looking for V1. So we can make V1 subject of formula, or we can just input the values directly here. So I will suggest make V1 subject of formula. So to make V1 subject of formula, we divide both sides by P1. So that this P1 will cancel this P1, and V1 is now standing alone, becoming the subject of the formula. If you don't understand this part of mathematics, you can meet me later for explanations, probably higher lessons. So in this case now, we go ahead to put variables. So V1 is equal to, what's P2 here? 6 kilopascals. Now when two things are together, they are multiplying. When 2 liters are together, they are multiplying, times V2 is what? 10 liters. All over P1 is what? 3. So we have the volume 1 will be equal to 6 times 10 is 60 all over 3. So the volume of the first container is 20 liters. Wow, that was big. So the volume of the first container is 20 liters. Now you can see here that when the volume increased, when the volume was high, the pressure was low. And when the pressure increased, the volume decreased altogether. All right, so we see that Boyle's law is proven from this solving.